Hi, this is the part 2 of our multiplying rational algebraic expressions. On the first video that I have sent, the numerators and the denominators of our RAE are in the form of monomials. So this time, I will give you some RAEs wherein the numerator or the denominator are not monomial. So for example, I have here binomials like x squared minus y squared and x plus y. So for you to simplify this, for you to multiply this, you are going to think first, observe first, which of these given are factorable. So on our given, obviously, x squared minus y squared is factorable. Because if you are going to recall on our topics on week 1, x squared minus y squared is under DOTS. Okay? So I hope you still remember how you are going to factor polynomials in the form of DOTS or difference of two squares. That's why on our last meeting or last week, on the first week of our discussion, I have told you that you have to master how you are going to factor polynomials, because that topic will be very helpful for you to understand about RAE. And then simplifying, because simplifying is also very helpful in the operations of rational algebraic expressions. Okay? And then, so you may factor out x squared minus y squared as x plus y times x minus y. Then, obviously, our 4 and our 16 here has the common factor, or you may also use factoring with the 16. So you may factor it out as 4 times 4. Because 4 times 4 is 16. And since we already have 4 on the numerator, so obviously 4 is the common factor. Then after factoring both the numerators and the denominators that are factorable, you are going to divide out common factor. So obviously we have here x plus y on the numerator and x plus y on the denominator. So this will be 1. And also with 4 on the numerator and 4 on the denominator, so that will be 1. Then you are going to multiply. So on the first fraction, we have left with x minus y over 4 times, on the second fraction, we have left with 1 over 1, and you are going to multiply or simplify and multiply. So your answer here will be x minus y over 4. So that is how simple it is. Okay? For our next example, let us have x plus 1 over 3x plus 6 times 6x plus 12 over x squared minus 1. Okay? So in this case, there are many factorable given here. So on the first fraction, the denominator is factorable, because we have the common factor on 3x and 6. So it is under factoring polynomials with GCMF. Okay? So don't worry with the numerator on our first fraction, because that is already prime. So this is not factorable. On the second fraction, on the numerator and the denominator, they are factorable. So our denominator is factorable because it is under DOTS. And our numerator is also factorable under factoring polynomials with GCMF. Okay? So you are going to factor out again the factorable. So as you have seen, we have here x plus 1 all over 3x plus 6. If you are going to express in factored form, will be 3 times x plus 2. I hope you still remember factoring polynomials with GCMF. Times, also with the numerator, 6x plus 12 will be factored as 6 times x plus 2. And since our denominator or second denominator is under DOTS, so the factors are x plus 1 times x minus 1. Then, divide out or cancel out the common factor. So, you can cancel out x plus 1 on the numerator and denominator. Then, 6 and 3. So, we have here remained with 2. Then x plus 2 is also common. But you have to take note that you can only divide out the common factor if one is on the numerator and the other one is on the denominator. If both the common factors are on numerators, so you cannot cancel them out. So again, make sure that one is on the numerator and the other one is on the denominator. So as you have seen, our first fraction here becomes 1 over 1, and our second fraction becomes 2 over x minus 1. Then you are going to simplify for you to have the final answer. So the product of this is 2 over x minus 1. Okay? I hope you get it. So what are the steps you have followed to arrive at the product of each of the given fractions? Okay, so again, number 1, you are going to factor out. Make sure that all the factorable given numerator and denominators are factored out. And then, you are going to divide out the common factors and then simplify and multiply. Okay? So, let us have another example. We have here 8x plus 4 over x plus 4 times, so this time I have trinomial on the numerator, x squared plus 7x plus 12 over 2x plus 1. So in this case, only the first numerator and the second numerator are factorable. Our denominators are already prime. So you are going to factor out the first numerator, 8x plus 4, because it is under GCF or polynomials with GCF, and the second numerator, x squared plus 7x plus 12, is under general trinomial or quadratic trinomial where a is equal to 1. Then you are going to express the factored form, so you will have here 4 times 2x plus 1 all over x plus 4 times this trinomial becomes x plus 3 times x plus 4 all over 2x plus 1. Then, after factoring out all the factorable given, you are going to cancel out or divide out the common factor. Okay? And then, you will left with 4 over 1 times x plus 3. So, you will left with 4x plus 12 over 1 or 4x plus 12. But sometimes, you have to simplify your answer. So, 4 times x plus 3 is also acceptable. Okay, is there any question? So again, the things you are going to remember or the steps on how you are going to multiply are AE. 1. Factor each expression. 2. Divide out common factors. 3. Simplify and multiply. Okay, so let's try if you really understand what I have given to you earlier. I have here 10x minus 40 all over x squared minus 6x plus 8 times x plus 3 over 5x plus 15. Okay? So, you are going to factor out all the factorable. Yes. So, the first numerator, 10x minus 40 is factorable. The first denominator, x squared minus 6x plus 8 is factorable. X plus 3 is not factorable. But 5x plus 15 is also factorable. So, that's why you will obtain 10 times x minus 4 all over x minus 4 times x minus 2 times x plus 3 all over 5 times x plus 3. So, na-factor na. Then, cancel out the common factors. Okay? So, you will left with 2 over x minus 2. Okay? Next, let us have this. X minus 3 over 4x plus 20 times x plus 5 over x squared minus 9. Okay? So, x minus 3 is not factorable, but 4x plus 20 is factorable. And then, x plus 5 is not factorable, but x squared minus 9 is factorable. Okay? So, we have here x minus 3 over the factors of 4x plus 20 are 4 times x plus 5. And the factors of x squared minus 9 are x plus 3 times x minus 3. So, after factoring, cancel out the common factors, and then multiply or simplify and multiply. So you will obtain 1 over 4x plus 12. Okay? Or 1 over 4 times x plus 3. Okay? So that's all for this. I hope you understand what I have discussed to you earlier. But for now, I will give you some pictures here. And you are going to find for the area of the plane figure below. So I have here, yes, it is the church of our municipality, of our city, General Trias. So I have here triangle. But this figure shows that the height here is b squared over 2 minus b, and our base here is b minus 2 over 2b. So you are going to find for the area of this. So you are going to apply the formula in finding the area of a triangle. Yes, correct. The triangle. Next, I have here, yes, blackboard. Okay? So you are going to apply what you have learned in finding the area of a rectangle. Yes, you are going to have area equals length times width. So that's why you are going to multiply s plus 3 over s times x squared over 3s squared plus 9s. And then apply the steps in multiplying. Factor the given or factor out the factorable given. And then divide out the common factor and simplify. For the last one, I have here the Maliksi type school building. So we have here the brace of our fence, steel fence. So we have here the figure, but you are going just to apply. I have here a line and I formed a triangle. So still you are going to find for the area of a triangle by applying 1/2 BH. So our h or height is y squared minus 4 over 9, and our base is 3y over y squared plus 2y. Okay? So just try to solve this so that you can practice yourselves on how you are going to multiply rational algebraic expressions using the figures by applying what you have learned on real situations. Okay? I also have here another examples. Oh, it seems that there are many trinomials, but I hope you can answer this, you can practice this out so that on our next meeting, you can have the correct answers here. Okay? You may discuss it with your classmates, okay? So that you can determine if you have the correct answer, or you may discuss it with your siblings or with me. If you have your free time, you can call me so that I can teach you and I can tell you the correct answer here. I also have here another given, so just apply all the steps on how you are going to multiply the RAE. Factor the factorable, divide out the common factor, and simplify and multiply. Okay? So I hope you will practice the remaining slides. And that's all for now. So thank you.